You are welcome to the GMAETS 41's live class. In this class, we are going to deal with organic chemistry, because we'll be looking at IUPAC nomenclature of what supposedly seem to be the last three homologs that students studying aliphatic hydrocarbons, or let's say aliphatic compounds, are meant to learn. The IUPAC nomenclature of supposedly the last three aliphatic compounds that students are meant to learn. And of course, these compounds, now the homolog we are talking about, include acid anhydride. It includes amines and nitriles. So once again, you are welcome to the live class as we look into these nomenclatures, right? And now, spilled. So we're giving attention to acid anhydrides first. Acid anhydrides. These are the ones you are going to consider first, after which we'll look at the nitriles, also known as alkanonitriles, and we'll conclude with amines. So once you join the class, give this class thumbs up. The GMAETS 41 is always right here for you guys. And of course, share the link to this class to your friends, to your classmates. For those in Unizik, remember today your school has resumed for second semester. And those in 100 level, of course, you need this topic a lot, very important. So I want to share this link to your departmental WhatsApp group, to your classmates, your friends, invite them to join the class. So like I said, we will be starting with acid anhydrides. Now, acid anhydride is a derivative of alkanoic acid also. In our previous class, you recall that we treated various derivatives of alkanoic acid, to include alkanoates, also known as esters, all right, to include acid chloride, and then we also dealt with acid amide. These are derivatives of alkanoic acid. The fourth derivative of alkanoic acid is acid anhydride. Okay, so we'll be starting with this to deal with the IUPAC nomenclature. First of all, the functional group of this acid anhydride is given as RCOO. Then permit me to use another shade of marker. This time I want to use blue, then COR. Good. Let me put prime here. Doesn't matter. So you see what I try to do here is you have this part RCO, and then you have this part COR prime, or simply COR. I've always explained that this prime I put here is to tell us, okay, there are some cases in which R prime might be the same as R, and then there are cases in which this R prime may be different from this R, but they are all alkyls, okay? They are all alkyls. You can have something like methyl here, you could have something like ethyl here, ethyl here. It's possible you have something like ethyl here and you have methyl the other side. So R and R prime may or may not be the same. Let us expand this functional group for you to see. Although I've actually held a class on functional groups to tell you, how these guys are being written. Okay, so this RCOO, look at it. Okay, that's RCOO. Now in alkanoic acid, you know that this is H in alkanoic acid. But what happens now is that this OH of alkanoic acid is removed and replaced with OCOR. Please permit me to do something here. The more correct form of this oxygen, I'm going to use blue shade because actually it goes with this guy. It goes with this guy. Since in alkanoic acid, what is being replaced is the OH by another, group of atoms. So looking at this RCO, okay, RCO, which is this first part called the acid. The acid group comes from the alkanoic acid, So the OH of alkanoic acid, usually with this alkanoic acid is OH. But in this case, the OH is replaced by another group, like I said, and that group is the anhydride group. That group is the what? Anhydride group. So we have something like O, C. And you notice that this oxygen is bonded to this carbon and this other carbon with a single bond. Then from there, you now have this oxygen, which is bonded to this carbon by a double bond. And of course, you have the R prime. So in expanded form, this is the functional group. Anytime you want to deal with the IUPAC nomenclature of this guy, you are expected to divide this at this point, break it at this point. Yeah, I can break at this point. It's as the same as maybe you may decide to break at this point because this oxygen is shared by both carbons. But all said and done, the interest here is when counting the longest number of carbon, the longest chain. Respect this carbon, and then count away. Count away in the direction of the carbons, like this one and then this one. So that's just what you need to take note of. All right, so I've shown you, the concept of the functional group of this guy. And so we are going to right away look at structures and then give the name. But before then, it's important for you to know how the parent name of the guys are being mentioned. In acid anhydride, you want to take note that we have simple anhydride. We have simple anhydride. Okay. And then we have what we can call mixed anhydride. Mixed anhydride. Okay. Now for simple anhydride, the alkyls on both parts, on both sides will be the same. This alkyl here and this alkyl here. But in mixed anhydride, the alkyls on both sides, they are not the same. They are not the same. Okay, so you want to take note of that. Now, how do we give the parent name of these guys? For simple anhydride, the parent name is simply alkanoic anhydride. The parent name of this guy is simply what? Alkanoic anhydride. But if we come to this mixed anhydride, the parent name is alkanoic anhydride. Alkanoic anhydride. Because of course, in that case, you know that this guy is different. All right, they are alkyl. The number of carbons on both sides of this oxygen. The number of carbons on both sides of this oxygen that combines these two carbons with a single bond. The number of carbons on both sides will be different. So in that case, you go with the name alkanoic anhydride. This one, simple anhydride, is simply alkanoic anhydride. Okay? Alkanoic anhydride. All right, let us pick our first structure to this guy. I've got this structure for you. Structure number 1. I have CH3, CH2, COO. You have CO, CH2, CH3. So we've got that structure as you see there on the board. Now, what is the IUPAC nomenclature of this guy? Now, the first thing you have to do is to locate that oxygen that is singly bonded to both carbons on both sides. And that oxygen is this one. Look at this. Because after this first CO, you have this oxygen and they have another CO. So there's going to be an identification here. That oxygen that the dotted line went through is this guy with single bond. So from there, you can now count 1, 2, 3. Count away. 1, 2, 3. You count away. Is that okay? You count away. So you see that the number of carbon atoms on the left and the number of carbon atoms on the right, they are the same. And because they are the same, we can simply call this 3 carbon atom is prop. Prop. So derivative of alkanoic acid in this case, remember I told you for simple anhydride, the name is simply alkanoic anhydride. Since you have prop here and you have prop here, this is simply propanoic anhydride. Propanoic what? Anhydride. That's the name of that guy. Propanoic anhydride. Very cool. Very cool. Once you say this, you notice, or you would see that the anhydride that you have here on the left and right hand side of the oxygen that is singly bonded to both carbons of the functional group, that carbon on the left and right, they are the same in number. All right, let us look at this one. Number 2. I hope this part did not cut off from view. Let me check. All right, that's good. It's within view. Once you connect to the class, you know what to do. Give this lesson thumbs up. And then you can invite your friends to join the class. So we have this. Next structure to consider. CH3, then CH2, COO, CO, and then CH3. Good. So all I have to do is to do the same thing. Identify that oxygen that is singly bonded to the 2 carbons around that functional group. Okay? And then we have this 1, 2, and 3. Then come over here, we have 1 and 2. Please take note that I can decide to write this functional group as COO, COR prime. As a matter of fact, this is the proper and most correct way of even writing the functional group. You know, this R not being there. The reason is because with this empty bond line, without fixing an alkyl R, we are saying that hydrogen still has the right to enter here. Hydrogen still has the right to do what? Enter here. Where in that case, this part will be metanoic. Metanoic. If you have hydrogen here with this carbon, then this part will be metanoic. So what I'm trying to say in essence, hydrogen can also fit in. So the functional group properly is even of this form. Okay? So you take note of that. Let me write all. You have it like this. So coming back to this, in this case we have 1, 2, 3, which is prop. We have 1, 2, which is 8. This is a mixed anhydride because the alkyl we have on the left and the alkyl numbers we have on the right, they are different. 3 carbons, 2 carbons. So the parent name will follow the format alkanoic anhydride. And what are the alkanoic, guys there? This is ethanoic. This is propanoic. So following alphabetization rule, ethanoic and propanoic, which one do you mention first? Alphabetization E will come before P. So this is ethanoic, propanoic, anhydride. That's the name of the guy. Ethanoic, propanoic, anhydride. Now take note that there are cases you can have, substituent, that is attachment on the parent carbons. And of course, if you have attachments on the parent carbons, don't panic. You follow the same principle as per what you've learned in IUPAC nomenclature, so far, where you would have to mention the name of the attachment that follows. Okay, for example, assuming that I have something like this, although I didn't consider any such structure, but let's assume I give you something like C. Let me fix hydrogen behind. HCOO, then COC, and then I have CH3, CH3. Okay. And then let me say I go this way, CH2, CH3. Good, something like this. Should I make this one even a bit more complex? Or I should just leave it this way. Okay, now let us look at this. Most times you are not so much bothered by the IUPAC nomenclatures of this particular group, but it doesn't mean that you cannot be tested on it. You can. So let us leave this structure and see. In the same way, you have this oxygen identified because that's the oxygen that splits this into two parts. So you go this way. This is 1. We have 1 carbon on the left. Now here, 1, 2. If you come to this second carbon atom, you notice that there are 3 branches. And you have to go in the direction of the longest chain. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So of course, 1, 2, 3, and 4 is the longest chain. That being the case, that leaves us with this as attachment or substituent, leaves us with this as substituent. So what do we do? Now, on the left-hand side, you have methanoic, because this is 1 carbon atom, meth. This is 1 carbon atom, methanoic, on that left. That was what I was trying to say here. The hydrogen can also enter this, part. It's not compulsory that it is carbon you must link. Okay, now, methanoic here, and then you look at this is butanoic, right? This is what? Butanoic, because there are 4 carbon atoms. On that part of butanoic, you have 2 attachments of methyls on carbon number 2. That, of course, is going to be 2,2-dimethyl, and then you follow the parent name. If this is methanoic and this is butanoic, which will you pronounce first? You pronounce the butanoic first. Is that not so? Which means you're going to have 2,2-dimethyl, butanoic, methanoic, anhydride. Let me assume that this guy is 3 carbon atoms. For example, the longest chain here is 3 carbon atoms. And the longest chain here, let us say, is 4 carbon atoms. I mean, a particular, member that, if you're using alphabetization rule, you would have to mention that one first. So once again, let us assume that this part is 3 carbon atom, which is propanoic. And let us assume that this part is 2 carbon atom, which is ethanoic. Right? And then you have attachments here. You know that the name will go following alphabetization. You have to pronounce that name alphabetically, right? So it's going to be ethanoic. Then you identify the attachment as you want to mention that propanoic part. Where let's assume they have just this attachment. Okay, this guy is not there. This one is not there. So the longest chain is 1, 2, and 3. Are you following, right? 1, 2, and 3 with this attachment. So it's going to be ethanoic, 2-methyl propanoic acid. Ethanoic, 2-methyl propanoic acid. Remember what I considered. Imagine that here, this part, you have 2 carbon atoms. Here, you have 3 carbon atoms. and you have one methyl attachment on this second carbon atom. In pronouncing the IUPAC nomenclature, we'll go, the parent name is meant to be ethanoic propanoic. That's what the parent name should be in that case. Where I have 2 carbon longest here, 3 carbon longest here. The one with 3 carbon longest on the other side has methyl on the second carbon atom as a substituent. So knowing that the parent name is meant to be ethanoic propanoic, because alphabetization, you pronounce ethanoic first before propanoic. You want to follow it in that order. Don't be scared. But you know that in the ethanoic part, there is no attachment, no substituent. So you just move on. Ethanoic. Then to pronounce that propanoic, you must indicate the substituent. Ethanoic hyphen 2 hyphen methyl propanoic acid. Anyway, let's just focus on what I have here. So this side is methanoic, 1 carbon atom. This side is 4 carbon atom butanoic. But will come before meth. Butanoic B comes before methanoic N, right? So I will have to pronounce this part first. But in pronouncing it, remember that you have 2 methyl attachments on carbon number 2. So that goes with 2, 2 dimethyl. This attachment is on propanoid, so propanoic. And then come to this part, methanoic, anhydride. That is the name of this structure. And this is how we are done with the IUPAC nomenclature of acid anhydrides. Nothing much difficult there. Just remember, if the anhydride is a simple anhydride, and when do we say that an anhydride is simple? That is when the number of carbon atom on the left of that oxygen that has that single bond to the 2 carbons, the number of carbon atom on the left and on the right are the same. They are equal. Look at it. R equal to R prime. In that case, the parent name is simply alkanoic anhydride. Then, if you come to mixed anhydride, that is the case in which the carbon atom on the left of that oxygen singly bonded to both carbon, and then the carbon atom on the right of that same oxygen, if they are not the same. So in this case, we say R not equal to R prime. In that case, the anhydride is mixed. And the parent name follows the pattern alkanoic, anhydride, which means you mention alkanoic twice, respecting alphabetization rule. If you have attachment, don't be scared. Don't be bothered. Follow the normal pattern. Follow the normal pattern, the normal rule. If it is time for you to pronounce a particular parent, indicate the attachment, the substituent on that parent before you conclude with the parent name, like I did in this case. 2,2-dimethyl, which are these substituents on butanoic acid. Oh no, this is butanoic acid, please, not propanoic. I'm sorry. 4 carbon atoms. Butanoic. Good. 2 methyl attachment on 4 carbon atoms as parent. So 2,2-dimethyl, butanoic, and then methanoic anhydride. So that is how you handle that. You take note that always, if you are dealing with acid anhydride, the name must end with what? Anhydride. All right. As a note also, look at this guy. Instead of propanoic anhydride, you may still choose to call this propanoic acid. So I can say, or you can call this propanoic acid. Propanoic acid in a case where you are dealing with simple anhydride. In case you see such thing, it is also allowed. Are you following, right? It is allowed where you could have the same number of carbons here, the same number of carbons here. It's simple. So you mention propanoic acid. You can do that. You can do that. So that is it. And we are done with acid anhydride. Like I said, we're preparing for NITRILES as the next guy of interest. We shall be preparing for NITRILES. So finish up what you have there on the board. Okay? Finish up what you have on the board. You can screenshot if you so wish as we move on to the next homologue, the nitriles. Okay, so we are looking at nitriles as the next functional group we want to give attention to. Nitriles. Now, nitriles, right? The parent name, the pattern it follows is very important as always, because once you know about the parent name, the pattern it takes, you won't have problems with that. So the parent name follows the pattern of parent name. Meanwhile, first of all, I want to take note, I think the functional group of these guys is this. Now, this bond line, hydrogen can fit in, alkenes can also fit in. If hydrogen fits in here, if hydrogen is to enter here, it becomes methanonitride, which we call hydrogen cyanide, which we call hydrogen what? We call it hydrogen cyanide also. But in organic chemistry, methanonitride, take note. So pattern of parent name is alkanonitride. Alkanonitride. So it is as if you have alkane, then remove the E ending of that alkane, E in alkane, and replace it with onitride. The E is replaced with what? Onitride. So the suffix of alkane, E, remove it, then replace with onitride. So if you have something like methane, to now become methanonitride, methanonitride. Are you following, right? If you have something like ethane, it will now become ethanonitride, okay? So you have that onitride there. That's the pattern of the parent name. This functional group, let me still expand it, something like this. That nitrogen is triple bond. That nitrogen is bonded to that carbon with that triple bond, so you want to take note of that. Now, I've told you the pattern of the parent name. The pattern of the parent name is alkanonitride. So one can have methanonitride, ethanonitride, butanonitride, and the rest of them. Okay, so that is it. You've known the functional group of nitriles. That thing in inorganic chemistry we call cyanide. Yeah, cyanide. Actually, that's what we are dealing with here. It appears in organic chemistry, okay, as a homologue on its own, because this CN is a cyanide group. And if you have CN as an attachment, if you want to consider it as an attachment, we can pronounce it cyano, right? But in organic chemistry, we consider this guy as being a terminal functional group. A terminal functional group. We don't pronounce it as an attachment cyano. No, we don't do that generally. We don't. Okay, we take it as a main functional group, a terminal functional group. So like I said, we have methanonitride, we have ethanonitride, propanonitride, butanonitride, pentanonitride, hexanonitride, and of course nonanonitride, and the rest of them. Okay, let's take our first structure. Once you connect this class, right away, hit the like button. Share the link to this class to, of course, your friends, okay? Let's look at these structures, and I want to believe the screen has not cut off any writing. Let me adjust this a bit. Let me adjust it a little. Let me adjust a little. Okay, so I think that's good. I've got this structure that we would look at. CH3, CH2, I have this. As a terminal functional group, that carbon that is bonded to nitrogen with a triple bond is always taken as carbon number 1. So going from there, this is 1, 2, 3, and what? 4. 4 carbon atom is but. So as an alkanonitride, as a nitride, right? It becomes butanonitride. So this is butanonitride. Cool. Let's look at the second structure. I've got this. So what's the IUPAC name of this particular structure? So once again, identify the longest chain, of course, knowing where to start your counting from. Like I told you, this guy is taken as a terminal functional group. Therefore, the first carbon is always the carbon of the cyanide group. Are you following, right? CM. So we have 1, 2, then 3. Coming to this third carbon atom, when you look at it, there are 2 branches from there. One goes straight, and then the other one comes down. Check the path that gives you the longest chain. This will be 4, 5. This will be 4, 5, 6. So of course you have to go down 4, 5, and what? 6. The longest chain is 6, which is hexanonitride as parent name. And then of course we have this as an attachment, a substituent. 2 carbon atoms as attachment on carbon number 3 of the parent. This is ethyl. So we could say on the third carbon atom of the parent, we have this ethyl attachment, which is 3-ethyl. No other substituent. So you conclude with the parent name, which is hexanonitride. Hexanonitride. Good. That is the IUPAC name of this guy. As simple as that. This takes us to the next one. And this next structure is actually extracted from UNIZIC organic chemistry past exam question, okay? We're going to find out how we give the name of that guy. I'll be using this side of the board, so we see what we've got there. Let me indicate UNIZIC. Chem 102 past question. You know, the course used to be called Chem 101. Yeah, Isotron 101. The code is 101, but of course changed. And so it's changed to 102, and we have to work in line with that now. So we have this structure, CH3, C. Then CH, and then CH3. And this second carbon atom, you have CH2, CH3. Then this, you have CH3 here. Good. Coming down, we have CH2, then CH3. And then here we have CH2, CH2, Cn. So this is the structure. What is the IUPAC name of this structure that we have on the board? So it's simple as usual. Determine the longest chain, knowing where to start your counting from. You locate the cyanose group, okay? That's CN group, because that is where you have your carbon number 1. Going from there, this carbon, this is linked. So this is number 2, number 3, and then number 4. Now, once you get to this number 4, you will notice chains of carbon branch from it. One went this way, the other this way. So if I have this as 4, if I decide to go this way, this will be 5, 6. If I decide to go this way, this will be 4, 5. On this 4th carbon atom, you have about 3 branches there. So this is 5, 6, 6, and 7. Or you go 5, 6, and 7. If you have 5 and 6, of course, you know that 7 is longer than 6. Which means from this 4th carbon atom, you go this way as 5. Okay, this direction is 6. 6, which is shorter than the 7. So you go this way 5. You can decide to either go 6, 7, or you can go down 6, 7. The choice is yours. Let me decide to go down 6, 7. That leaves us this as a substituent, this as a substituent, and of course, this whole unit as a substituent, this whole unit as a substituent. Now, if you look at this whole unit, this side as a substituent, taking this as carbon number 1 attached to the parent, you notice that from this carbon there are 2 branches, either this or this, which you will now have to determine the longest direction to take, whether to go this way so that this becomes a substituent on a substituent, because this whole unit is a substituent. There are 2 as you can see here, 1, 2, or 1, 2. So we have 2 carbon atoms as a substituent on carbon number 4 of the parent. But on that 2 carbon atom, 1 other carbon is an attachment. If I decide to go this way, 1, let me use black shade, 1 and 2. That the longest chain in this substituent part is 2 carbons, which is ethyl, you know that. Then this will be taken as a substituent. If you decide to go this way, 1 and 2, this will be taken as a substituent. However you do this, you still get the same name. However you count, you're still going to get the same IUPAC nomenclature. Even this guy, I went this direction downward. Instead of going 5, 6, and 7, and then taking this as a substituent. However I do that, I will still get the same structure, or the same IUPAC name rather. So let us analyze the substituent we have there, the attachment, and then we give the name of this structure as we have here on the board. And that would be the end, I suppose, of the nitride groups as we conclude everything about IUPAC nomenclatures with a mean. No time. I know, having done that, GMAETS 41 has conquered GMAETS 41 has conquered organic chemistry in terms of IUPAC nomenclature fully. And what more? We talk about preparations and properties of each of these homologs, starting from alkanes. But like I've always rightly said on this channel, the pre-recorded video lessons of these stuffs are already available. Remember, you can become a channel member and platinum level or diamond level. Are you getting me right? Become a channel member. That will give you exclusive access and much more benefit to video lessons, live classes that are meant for channel members only. And of course, it gives you room for further assistance from GMAETS 41. It could be assignment given to you from school and whatever. Could also be prioritizing your questions. You can ask questions directly and you get a response. Because all these benefits go with becoming a channel member, like I said. Click on the Join tab and select the GMAETS 41's platinum or diamond level as regards which is convenient for you. Okay, we move on. We are all used to this substituent already. This is methyl. This substituent is 2 carbon atoms. 1, 2, 1, 2. It is ethyl. There is no other substituent on this substituent. So simply 1, 2. This carbon is linked to the parent. So you count 1 and 2. Because you have to count the longest chain in that substituent part. So this is ethyl. This is methyl. Coming to this part now, you notice that we have these 2 carbon atoms. Let me use blue shade of marker here, 1 and 2, so you don't get confused. So that's the numbering. We have 2 carbon atoms as attachment, as substituent on parent carbon number 4. But this substituent you have here, on carbon number 1, you have this methyl as an attachment. You know, that is what we call substituent on substituent. Where, of course, this substituent will bear the name of this substituent as parent, and then this whole substituent will now be attached to carbon number 4. Are you following? Of the main parent. Okay, now the name of this guy is methyl, as we all know. This is ethyl, as we all know. This guy is 1-methyl ethyl. What does that mean? On the first carbon atom of this ethyl attachment, you have a methyl attachment. So we have been able to analyze the name of the substituent. So what is more? We now have to follow alphabetization rule to determine the attachment, the substituent that will have to be mentioned first. Am I communicating? So I have methyl N, ethyl E. Here I have methyl ethyl. Methyl ethyl. That's what I have here, because we have methyl attached to ethyl. Now, if I give you a dictionary, I say you should locate methyl, locate ethyl, locate methyl ethyl. Which will you see first? You'll agree with me that following alphabetization or dictionary pattern or ordering of alphabet, ethyl will come first. And that ethyl is on parent carbon number 5. So the IUPAC nomenclature will be on the 5th carbon atom, you have ethyl attachment, which is 5-ethyl. Now, I have methyl and I have methyl ethyl. Methyl ethyl, that is M and E. But here I have only N, right? If you're giving dictionary to locate methyl only and then locate methyl ethyl, you'll agree with me that methyl will be found first before methyl ethyl. Therefore, this methyl will come, which is 5-methyl. 5-methyl. Now you see, ethyl and methyl, both of them are found on carbon number 5. There is this thing that sometimes some students ask questions on, or they go to committing that error. And what is that error? Since you have ethyl and methyl on carbon number 5, why not just say 5-ethyl methyl? You don't do that, please. These substituents are 2 different substituents. Although they are both alkyls, but they don't bear the same name. Therefore, you have to split them. 5-ethyl, 5-methyl. So take note of this if you are confused about that before. We are now left with this last substituent. And this substituent, if you look at it, where we have substituent on a substituent, it is on carbon number 4 of the main parent. So we are going to write on the 4th carbon atom of the parent, hyphen, on the 4th carbon atom of the parent. Now you are expected to put this in parentheses anytime you have substituent and substituent. I've said this time and again in previous IUPAC nomenclature classes. So I'm going to open this bracket, the parentheses, and then I will write the name of this substituent, which is 1-methyl ethyl. 1-methyl ethyl. 1-methyl ethyl. Good. Then somebody will say, okay, if we could mention this as 1-methyl ethyl, why could we not mention this one as 5-ethyl methyl or 5-methyl ethyl? You don't do that, please. Look at this. This methyl is an attachment on ethyl. Methyl is attached to ethyl. It means that ethyl gave birth to that methyl there. In this case, it's not like that. In this case, you notice that carbon number 5 of the parent gave birth to methyl separately and gave birth to what? Ethyl separately. So these 2 guys will follow with the main parent. But you see this guy, you are going to analyze it separately because it is substituent and substituent. This main parent, carbon number 4, gave birth to these two carbons. And then these two carbons on carbon number 1 went ahead and gave birth to this CH3. It means that this methyl will bear the name of this ethyl as parent. Then finally, this guy will now bear the name of the main parent, since this two carbon atom methyl is attached to the main parent. That is why we analyze on the 4th carbon of the parent. You have this substituent on a substituent. 4 into 1 methyl ethyl. And there's no other attachment. The longest carbon atom is 7. And that 7 will be heptanonitride. Heptanonitride. So the name of this structure as you have there, the IUPAC name is 5-ethyl, 5-methyl, 4 into 1 methyl ethyl heptanonitride. And I hope you learned something cool from here with explanations I gave regarding what you should do and what you should not do. All right, I'm trying to ensure that everything is within view. That's good. So finish up what you have on the board, and of course you can screenshot so that we move on to the last homolog whose IUPAC name you are expected to know. The last homolog whose IUPAC name you will deal with in this course. Say, guys, for those in advanced level, like UNIZIG, your school resumed today. You don't joke unnecessarily. When you come to online classes, it's something you can connect to the class from wherever you are. You wait until everything kicks off fully, and then you start complaining that you are not being taught what this lecturer is doing, you don't understand it. I've always said this, hey, you have no right generally to go speaking against lecturers as per maybe whether the way the concept is being presented or how you are taught, whether you understand or not. Yeah, I know it's their duty to lecture you, understand that, to lecture you. And I want to tell you something. Lecturing is actually a one-way communication. So if any lecturer decides to even go extra mile to like break concept down, everything, the lecturer is doing so much. Yes, I must tell you the truth. Lecturing is a one-way communication. And that is why I want to understand something, that university is a research institute. Yes, it's a place where you go for further learning. So the truth of the matter is that scholars are expected to be up and doing, to work hard, go extra miles. Once your course outline is given to you, once you have access to your course outline, in fact, you can finish your course outline before your lecture kicks off fully. It's possible. And this is one of the big secrets of people who blast first class. Must tell you the truth. Either they get this information about course outline on time, and then following up certain platforms like GMAETS 41 and other platforms dedicated, yes, to giving the best. Not just those that are out only to maybe, get sources and other things from you. We understand that, of course, somebody that is working should be paid in one way or the other. But I'm talking about people whose main focus, yes, is a passion to impart this knowledge. For we know that once that passion is there imparting, whatever income can follow naturally. That's the truth. That's the truth. So these ones, they link up with such platforms. And before you know, all these things that many students complain, I know the kind of, messages students send from different universities. I'm not even talking about UNIZIG, from different universities. So it's not just about a particular university, but like I said, this is lecturing, a one-way communication. Normally in a lecture, you're not even meant to ask questions until the end of the lecture. So you can see the disadvantage on its own. Not all of us have what it takes to maybe, okay, I have a question, you jot it down, you wait until the lecture is over, you can now hand your question to the lecturer. Lecture is something that if you have a question, you're meant to wait till the person is done with the lecture. But again, that has its own disadvantage, because the question that the learner, a scholar may have, the scholar may forget it before the lecture is over. Or maybe along the line, the scholar might be discouraged of not even wanting to ask the question again. So some of all these things, you can handle these challenges by making sure you go extra miles in your learning. Go extra miles. And going extra mile, one of such things is making sure you take extra lessons. That's the truth. Even though Mr. A or Mr. B might come and tell you some things, extra lessons you don't need. Many people need it. Many scholars need it. That's the truth. And of course, that's one thing that technology has done, making learning, homely. Like I said in our previous class, you can select a teacher. Yes, online. In GMAETS 41 is one such. Okay, that you can select. So as you follow up with all this, by the time you will do it in lectures, it will seem as if you are just revising. You already know what is being done. If for any reason you miss lectures, because let me tell you, attending lectures 100% is very, very low. Sometimes it could be health challenge. Sometimes it could be that you don't even have transport to go to school that day. Sometimes it could be that, you are hungry, nothing to eat to go for the class. These things are happening. It could be transportation. You don't have the transportation, like I said, to go. It's even possible that you are in a lecture. You are inside a lecture hall, taking lecture, but you are not there. Yes, it happens. Some persons might be absent-minded while class is ongoing, even though it is not advisable. You want to work on that, work against it. But it is something that is natural. Maybe after stress of the day and you have lecture later, might find that your brain might not be in the mood of assimilating anything. So you're just in the class, you're looking, make una finish so that we will go home. It's happening. So platforms like this will make the learning, easy going for you, so that the stress will be reduced. Let us round off with the last homologue. Like I said, with this last homologue, we've actually covered 14 homologues, starting with alkane, alkene, alkyne, alkanols, alkanals, alkanones, alkanoic acids, derivative of alkanoic acid to include the esters, alkanoate, the acid chloride, the acid amide, and then today we talked about acid anhydride, and I've just finished the nitriles. We'll be concluding with the amines. All right, so I'm wiping this as we move on to amines. I'm not teaching English here. Some persons might pronounce that as amine. Amine, it's your business. If I decide to pronounce it amine, it's also my business. Okay. I pronounce it amines. Amines. And of course, that's the correct pronunciation anyway, but it really doesn't so much matter. As long as you know the functional group there and the homologue we are dealing with. Good. Amines. Now, generally, the functional group of amines is RNH2. In fact, NH2 is what defines that. But although we cannot leave this bond line open, we can't. Whenever you are dealing with organic chemistry and you're talking about amines, you don't leave this bond line open. Like, it's not ideal to write it this way. It's not. Because like I said, you see, there's something I've observed when you are dealing with organic chemistry in terms of the functional groups. Leaving this bond line open without indicating what should be here means that it is possible for hydrogen to take that position. It is possible for hydrogen to enter. But why is it that in this case, you don't leave that bond line open? We must fix in, an alkyl there in this case of amine. Why? If you leave it open and you said, okay, hydrogen can enter, if hydrogen enters, this thing is no longer organic compound. It becomes ammonia, NH3. Is that okay? But by the time I close this with alkyl, we know that, okay, fine. What can enter here are chains of carbon. is carbon or chains of carbon. If it is one carbon, it gives you the first member, the meth. The meth. 2 carbons, the eth. 3 carbons, the prop. 4 carbons, the but. Are you following? And the rest of it. So the functional group goes with this R indicated. I hope you are learning, right? But there's something that is important for you to know about this NH2. Although we call this functional group amine, but depending on the positioning of this NH2, the name of this structure can also go with amino. It can go with what? Amino. And it happens with the first class of this group. The first class of this group is called the primary amines. So there is how primary amines can be written with respect to the position of this NH2, and instead of bearing the name alkylamine, it will now bear the name amino alkane. So what am I trying to say in essence? I am trying to make you understand that this NH2 can also be considered as an attachment. It can be considered as an attachment. As a matter of fact, this functional group is not considered a terminal functional group. It is not. It is not. Because we can take this NH2 as an attachment. And when we have this NH2 as an attachment, it becomes amino. Amino alkane. Amino whatever. If it is NH2, you have it, let's say, in an alkanol, it can be amino alkanol, as the name of the alkanol can go. Am I communicating? So you take note that this guy, the functional group of amine, is not a terminal functional group. Again, however, for primary amines, and this is the general representation of primary amines, if the NH2 is found on carbon number 1, if it is found on carbon number 1, that guy becomes terminal in that case. And although I think if I talk about the pattern of the parent name, it will make more sense. So let me wipe this as we move on. So pattern of parent name, but before then, classifications of amines. Classification of amines. Good. Classification of amines. I hope this did not cut off. Let me see. Classification of amines. Please, like I said, once you join the class, like the video. Like this live class that is ongoing. Remember, GMAT 41 is committed to the process, right? Irresistible. The commitment is absolute. Maintaining the integrity and, of course, the consistency. Later tonight, God's willing, I will be releasing the GMAT 41's online video lesson classes. The timetable will be released. So if you are in advanced level university, you know the days you might be having some, classes online. If you are in secondary school, high school, right? Grade 10, grade 11, grade 12, corresponding to SS1, SS2, SS3 of Nigerian system of education, right? You know the days you have your online classes. Then for those in basic level, you could have younger ones in basic level of learning, primary 4, primary 5, primary 6, which corresponds to grade 4, grade 5, grade 6. Then JSS1, JSS2, JSS3, those level are basic level of learning. JSS1, 2, and 3 correspond to grade 7, grade 8, grade 9. You will also know when your classes will be holding on the GMAT 41's basic class channel. For those in basic class, we have a special channel dedicated to these scholars. Yeah, there you won't see any advanced level stuff. You won't. You wouldn't even see any senior secondary school stuff, stuff of grade 10, 11, 12. You won't see them there. Grade 10, 11, 12, and then advanced level, your works on this particular channel, GMAT 41. Then for basic scholars. We have a dedicated channel. The name of the channel is GMAETS 41 Basic Class. GMAETS, you spell it together, that 41. You don't space anything, and you don't put hyphen, you don't put this. If you are spelling that GMAETS 41 for that channel, you remove it, just GMAETS and then together 41. Don't space the 41, don't. Then after typing GMAETS 41, space, basic, space, class. You need to subscribe to this channel. Why? It will be helpful both to you and to your younger ones. Remember, all these things you're studying in higher level, as the case might be, they have their roots from basic level. So sometimes there are certain things you might be finding difficult, to understand at this level. Certain basic knowledge can assist you, especially in the aspect of mathematics. So subscribe to that channel as well too. If not for you, if you feel so, you feel that, if not for you, if you have younger ones, they need it. You can also use that channel to teach them. So when they meet you, uncle, auntie, they gave us assignment from school, you will not be dodging. Some of you will run away and leave home. You leave your house that day. Why? Because the younger one wants you to assist him or her with assignment. You know what I'm talking about. So classifications of amines. We have primary amines, right? Primary amines. And primary amines, the functional group is RNH2. Primary amines. How do we give the parent, that is the pattern of the parent name, okay? The pattern of the parent name, how is it being given? So I'm going to write pattern of parent name. Pattern of parent name. Pattern of parent name is alkylamine. Alkylamine. Just like that. So you could have something like methylamine, ethylamine, propylamine, butylamine, pentylamine, and whatever. So you see, alkylamine. So this thing you are saying is amine. As long as you have that NH2, okay? Amine. Alkylamine. So you mentioned the name of the alkyl. Imagine if this R here contains just one carbon. One carbon is meth. That will now be methylamine. If this R here contains, say, 2 carbon atoms, 2 carbon atom is 8. So it's going to be ethylamine. What if this R contains 9 carbon atoms? With 9 carbon atoms and you have NH2 at the end, that becomes nonylamine. We move on. If there's an attachment, you handle the attachment as usual. Secondary amine. Secondary amine. Secondary amine, the functional group goes this way. So you notice something, that the number of hydrogen atom on the nitrogen reduces. And then you fix another alkyl. This is secondary amine. Secondary amine. I was going to say something about primary amine, but I forgot at the time. There are some cases where this primary amine will not follow alkylamine. I talked about that, where that NH2 is no longer, at the end. If it is seen within the extreme carbon, between carbon atom, in that case, it becomes amino alkane. So I don't know what I'm going to do at this point, because I don't want to wipe this. I'll give it to you as a note when I am done with tertiary amine. I'll link a note to this primary amine, where you can the parent name of amine, primary amine, can follow the pattern amino alkane. So let's move on. Parent name of this guy, the pattern of parent name. Pattern of parent name is this is alkyl. Going to indicate. Remember that something substituted in nitrogen. Yes, something substituted hydrogen in that nitrogen. So you must indicate N. That N means on nitrogen there is, a foreign guy, a foreign body, right, that has replaced nitrogen there. So, alkylamine. N, N-alkylamine, right? Let me see. N-alkylamine. N-alkylamine. Alkylamine. Because you need to indicate the name of the alkyls you have there, right? If R and R prime are the same, it will become di. To become what? Di. You wouldn't go to say alkylamine. This alkylamine, I gave it as a general format in a case where, okay, let's assume that this is methyl and this is ethyl. You know, if this is methyl and this is ethyl, this guy will now become N-ethyl-methylamine. N-ethyl-methylamine. Am I communicating? Okay, but imagine that this R and R are the same. They are alkyls, they are the same. So that this is methyl and this is methyl. There will be no need of saying N-methyl-methyl. It will simply be dimethylamine. The methyls are the same, so simply dimethylamine. But I had to use this format at least to guide you in case you see something different. If they are the same, you can use your, your IQ. You can use, because you'll be meeting cases where if you have the same group, the same attachment on a particular carbon, that attachment is mentioned. If there are two of them that are the same, di of that di. Are you following, right? So you want to take note of that. Oh my God. Gosh. My dear lovely brother, is it? I am calling you right away after this. I am going to reach to you. See, right here on this live class, I've met my very good brother, not just a friend, and let me say we've done each other some wrongs. Yeah, we have, because we're not supposed to go apart this long. I've wronged you. Bethel, I really missed you so much, I'll link up with you right today. Thank you for the commendation here. I appreciate it. Thank you so much. All right. So having said this about these secondary amines, don't worry, when we pick the structure, you will learn much more better what we mean by this. I just hope I remember the note I want to give regarding primary amines. But if I forget, good, that makes me a human. But I will try not to forget when you pronounce that guy amino alkane. All right, classification number 3 is tertiary amines. Tertiary amine, right? The functional group of that guy is this. Now notice, in secondary amine, one hydrogen from the primary has been replaced or was replaced with alkyl group. Now in this case, the remaining one hydrogen will be replaced with another alkyl group. So I'm using this issue of prime to indicate a certain level of difference. Are you following, right? But it is possible for all these alkyls to be the same. It is possible for all these alkyls to be the same. It is very much possible. But I'm going to give you the name in the direction of assuming that they are not the same. So pattern of the parent name. Pattern of the parent name is N. What is the meaning of this? That NN means that on that nitrogen atom, there is a double attachment. There is a double replacement. Of course, you know that in the amine group, that nitrogen has two hydrogens directly attached to it. Now, the two hydrogens have been replaced with alkyl group. Are you getting me right? Good. Have been replaced with alkyl groups. So you need to indicate that the two hydrogens have been replaced. In the case of N, N-alkyl stuff is here. Only one of the hydrogen on that nitrogen was replaced. For tertiary, the two hydrogens have been replaced. So it's going to be NN, alkyl, I don't know. Can I squeeze it here? Alkyl, then amine. We met something similar to this under acid amide. You know, one of the derivatives of alkanoic acid under acid amide. All this concept of N. You know, you can visit our live class on IUPAC nomenclature. You know, I think in that class we started from alkanone, I guess so, either alkanone or alkanoic acid, yeah, up until I think acid chloride or thereabout. So the under acid amide, you meet this concept of N-alkyl, whatever, N, alkyl, and the rest of them. So that is that, and I think you are set for this parent name stuff. Are you following, right? You're set for this parent name stuff. Let's deal with the notes. I said I want to give to you notes. For primary amines, now that primary amine, you know, it's RNH2. If the NH2 is not terminal, comma, the pattern of the parent name, becomes amino alkane. Now let me indicate X, amino alkane, where X is position of the NH2. You know, position of the carbon atom bearing that NH2. So you could have something like 2-amino-butane, 2-amino-propane. You can have something like 4-amino-nonane. So you see, in that case, the NH2 is no longer on carbon number 1. Which means that in this case, we follow the pattern alkylamine. That is when the NH2 is a terminal guy. Terminal. Here it is not terminal. So let me indicate. If NH2 is not terminal, you want to take note of that. That's the condition. When it is terminal, it means that the NH2 is on carbon number 1. So anytime you have 1-amino alkane, every 1-amino alkane is the same as alkylamine. As a matter of fact, the proper nomenclature, the proper way the International Union of Pure and Applied Chemistry, IUPAC, approves the naming of those guys is alkylamine. In the case of 1-amino alkane. If it becomes 2-amino alkane, you can't go this way anymore. You can't go as alkylamine anymore. It will now become X-amino alkane, right? You have to indicate the carbon atom position bearing the NH2. All right. This thing cut off. Let me adjust the camera. Let's see. Let me adjust the camera. Good. So you want to take note of this point that I've made, very important. So finish up what is on the board so that we can conclude by looking at some structures under this guide. So you see, all these thoughts are things that, yeah, when you read your textbooks, two things are involved. Either you are able to interpret this, or you don't understand what is there. You know, I respect textbooks. There is no argument to that. But the truth of the matter is that the level at which the world is operating technologically now, and Knowing that when you talk of textbook, usually someone explains what is in that textbook. Yes. If you're reading the textbook, you see that someone teaches you what is in that textbook and then you read it for proper understanding, or you on your own, you try to make blind interpretation to what you are reading. Yes. I use the word blind interpretation because whenever you are reading a textbook where someone has not taught you something on it, two things are involved. Either your interpretation is correct or your interpretation is wrong. That is why in selecting a textbook to read, the author matters because style of writing is very important. And you see, one other challenge with text in that case is all details necessary that you are expected to know about a particular thing cannot be written down on paper. Are you following right? And that is why attending classes is very important. So when you resume lectures, make sure, try as much as you can to be up and doing with your lectures. I always encourage students attending lectures. Yes, I run classes, off lecture stuff, tutorials and other things. But I never, and I repeat, I do not discourage students attending lectures. Go for the classes. Go for the classes. And I want to say this, if perhaps you learn very well from classes, your lectures, then further too much extra stress is not necessary. It's not. Because if you are following through from there, what else? What else? It's when you find out there are loopholes, you can now go for extra assistance. Of course, I understand that in this present dispensation, that loophole is always there. Yeah, sorry to say, it's always there. We pass through it, so we know what we're talking about. And the more the days, are going by, the more the loopholes are coming up much more, especially because of the economic situation, of the country and everything. So you want to make sure that you try to make yourself available to this. You can apply for tutorial classes, And I've also encouraged you to apply, even if it is physical tutorial. Please make sure you don't joke with online tutorials, because that is actually where you learn the most. I must be honest. In online classes, you learn at your own speed, at your own pace. Number two, you select your teachers. If you don't understand Mr. A's work, you can understand Mr. B or Miss A or Miss B. There are many creators. So the persons who you understand, where you select your teachers. It's not like in a school system, physical school system, where of course you have no choice. Someone is imposed on you. These are things I really want people, even parents, to understand, and and students to understand about when it comes to online. You have the right choices to make. In physical setting, you don't have anybody that is imposed on you. You work with that person. So what if you don't understand the pattern of teaching of that person? And then even in the physical class, why though it is good, because you can never kick it off completely. The truth is, there are sometimes, like I say, you might be seated in physical class, but you don't even understand what is happening there. It's a function of brain, especially when the law of diminishing return, as economics proposes it, when it sets in. Of course, we know that law of diminishing return also, it sets in into our brain sometimes. This is where your being able to learn online comes into play and helps you. Because the only way you can survive in that case is someone else giving you further assistance, or you go online and source for information on that. So please, I am using this opportunity to encourage scholars, right? Encourage scholars, encourage parents. It's important we get to understand the importance of online studies. Okay, so I'm going to wipe this, and like I said, we'll be concluding by taking some structures and getting to learn their IUPAC nomenclature. Remember, without you knowing the name of these homologues and the IUPAC nomenclature, you cannot really withstand the preparations and and properties, especially chemical reactions of these guys. Because the things that you are preparing are these guys, right? And the reactions, it's these guys that undergo the reaction. So you need to know their names. You need to know how their molecular formulas are written. From the structural formula, like you've been seeing, we write to show all those things. You can condense them and write the molecular formula. When you get the molecular formula, if I tell you, okay, the Clemmensen reduction of carbonyl compounds produces dash, you will know the homologue is going to produce. And if I decide to be specific, I'll tell you that maybe propanone undergoes Clemmensen reduction, because if it's undergoing Clemmensen reduction, you use amalgamated zinc, that is zinc amalgam, in concentrated hydrochloric acid. That's a reagent called, that is used in Clemmensen reduction reaction. If I tell you that propanone undergoes Clemmensen reduction to produce dash, and then in the option, I specify the name of the guy being produced, you have to know the names. So you don't joke with IUPAC nomenclature. That is going to open your mind wide to further dealing with all those, chemical reactions of these guys. For example, like Clemmensen reduction of propanone is going to give you propane. So if I give you the nomenclature of these guys, maybe the molecular formula, in the propane now I write C3H6, C3H8, C3H4, and then C3H7OH. What is the correct answer? The concept of nomenclature will help you through all this. And like I said, with today's class, we've actually rounded off. With today's class, rather, we will be rounding off everything on the IUPAC nomenclature, so that names of organic compounds, at least aliphatic compounds, will not be a problem. For those in 200 level, at least I speak to those in Unit 6 specifically, I'll be teaching you IUPAC nomenclature of bicyclo compounds. Yes, bicyclo compounds. So you want to prepare for that. God willing, tomorrow we're going to have that class live online. Meanwhile, today, for those in 200 level, I'll be taking you on ordinary differential equation, ODE. That's going to be tonight. Okay, so let's look at these structures that I've got here. Like I said, GMAETS 41 is a total package. It's a total package. As long as your basic STEM subjects are concerned, because your basic level of learning is very, very important. Yeah, when I say basic, I'm actually referring to 100, 200, and 300 level works. Because in university, after 100 and 200, what else? From 300 is the knowledge of all this basic stuff. In 100 and 200, you apply to things you'll be meeting. And if you perform very well in your 100 and 200 level, let's assume a student beats first class, 100 level, beats first class, 200 level. Believe me, I put it to you, there is 90% chance, are you following, or certainty, confidence limit, that such student is going to graduate with first class. That's the truth. So your studies in 100 and 200 level, don't joke with it. Do not. Someone that is even pursuing master's program, second degree after first degree, it is your knowledge from your 100 level, 200 level, added to the things you learned in 300, 400, and 500 level, depending on how many years your course is, that will propel you into withstanding whatever you're going to do in your master level. Don't joke with your 100 and 200 level. Don't joke. I've been there, and I'm telling you with full experience and confidence. The first structure we have is this: CH3, CH2, 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 and then NH2. So this is the structure we have. Now, if you look at this structure, you'll agree with me that this is an amine homologue, right? It's an amine structure because, of course, you have NH2. So be thinking amine. Now, locate that amine, find out that amine is on carbon number 1. Carbon number 1 can either be from the right or from the what? Left. In this case, carbon number 1. NH2 could have been here. So become NH2, CH2, 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 and then CH3. So since this NH2 is on carbon number 1, this is terminal in this case. It is terminal. Okay, one amino butane. Because there are 4 carbon atoms here, let's even indicate, even if it's not absolutely necessary for this structure. 1-amino-butane. But professionally, as a chemistry student, this is actually butylamine. 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 Okay, but like I said, let me just say or. I'll write this one very small. 1-amino-butane. That is, if you're pronouncing this as an alkane. Remember I said all 1-amino-alkane, the pattern of the parent name properly is alkylamine. So in this case, you pronounce the alkyl first. This thing you are seeing here is butyl. Butane is C4H10. But if you count these 4 carbon atoms, the number of hydrogen atoms you will see there will be 9. This is butane, C4H10, butane, A. If it becomes C4H9, that becomes an alkyl, because this alkane has lost 1 hydrogen. So that becomes alkyl, butyl. Then you conclude amine, butylamine. I hope you're learning, right? If you want to go as an alkane, the choice is yours. If it is in CBT case, objective test case, the options provided for you will determine how you name this structure, either as 1-amino-butane, if that is what is given to you, or butylamine. But the point is, 2 of them cannot be given as options in a particular question for this structure. Like maybe I give you this structure, then option A, you have butylamine, B, 1-amino-butane. No examiner should do that. That would be wickedness. You know? Of course, I believe no one should do that, and no one would. Yeah, because both of them are the same, and they are acceptable. Just like I say, for every 1-amino-alkane, the proper way is going as alkylamine. We move on. Number 2 structure I want to see. Now look at this. CH3, CH, NH2, CH, and then CH3. You see this? Once again, locate your NH2. And you find out that your NH2 is no longer terminal. Rather, it is within the carbon skeleton, within the parent chain. So in this case, you can't pronounce this structure as alkylamine anymore. Rather, it becomes X-amino-alkane, where of course that X indicates the position of the carbon atom bearing the NH2. Now you want to determine where you will start your counting from. Is it from the left or from the right? And once again, the direction to start counting from follows everything you've learned and I've taught you all through IUPAC nomenclature with respect to where you start your counting from. Remember, what determines where you start counting from is greatly linked to the functional group. Functional group of amines is this guy that has NH2, then linked to alkyls, right? This NH2. Now, where is it closest to? It is closest to the left in this case. Or you can say which direction we give the lowest sum to that functional group. If I go this way, 1, 2, on the second carbon atom, you have the NH2. If I come this way, 1, 2, 3, on the third carbon, you have it. So 2 plus 3 will give you 5. 2 plus 3 will do what? Give you 5. But anyway, like I said, 1, 2 anyway, this direction 2, then 1, 2, 3, this direction 3. Which direction gives you the lowest sum? 2. All those things are just waste of time. I think we've covered all those stuffs. NH2 is closer to the left than it is to the right. So counting will start from here. On the second carbon atom, you have that NH2 group. So this becomes 2-amino. 2-amino. 4 carbon atom is but. As an alkane, it becomes what? Butane. So do you see? When the NH2 is on carbon number 1, it becomes butylamine, 1-amino butane. But now the guy has shifted from carbon number 1. You cannot call this an alkylamine. It's not done. This is the pattern. X-amino alkane, which in this case, the X is to the position of that carbon atom in the parent chain bearing the NH2. Amino is the name of this NH2 considered as an attachment. Then butane, the longest carbon chain. We are moving and we are moving very much closer to the end of this. And I love what is happening, you know, because covering this nomenclature, 14 of them, like I said, is not easy. It's not an easy one. These guys are primary amines. They are primary amines. Let us look at this one. Still primary anyway. C6H5 and then NH2. C6H5NH2. You see this? This guy is not an alkyl. In chemistry, you see this C6H5. It is obtained from this guy, C6H6. C6H6 is benzene. This guy is benzene. Just like we have alkane. I told you if an alkane loses one hydrogen, it becomes alkyl. The same thing is if benzene loses one hydrogen, there is a name we give to the resulting homolog. We call it the phenyl or the aryl. It's actually aryl, yeah, aryl. Just like you have alkyl. You now have what? Aryl. Look at it. Benzene minus one hydrogen. Benzene minus one H, one hydrogen, will be equal to a group called the aryl. We use AR to represent the aryl. Just like you have alkyl. Alkyl gotten from alkane. When alkane loses one hydrogen, you say, okay, alkyl. And we use R to represent it. So take note, guys, if you see AR anytime in your study of organic chemistry, this is not argon. In organic chemistry, it is taken as a real group, aryl. And in this case, specifically, the aryl is phenyl. That's the name given to that guy. Phenyl. So you want to take note of that. Here we have it as phenyl. C6, instead of H6, you have H5. So this guy has lost one hydrogen, becoming phenyl. The general representation of this, just like this thing we had here, RNH2. We could also have something like AR, then NH2. Good. This one represents aryl, phenylamine. It's just that generally, you know, in 100 levels, you moving on, you meet more of this instead of the aryl group. So this is the most used guy, okay? Aryl. All right, let us move. Alkyl rather. But once you have the case of benzene losing one hydrogen and then attached to NH2, it becomes aryl. And this guy specifically, the name of C6H5 is phenyl. So this is phenylamine. Phenylamine. Wiping this. We're moving on. Let's look at the next structure we have. Think I am done with the structures I'd like you to give attention to for primary compounds. Let's look at this one, number 4. We have this CH3, NH, CH3. The generator is about going off. So if it goes off, we'll use the natural light. So good. If it goes off, we use natural light. Now, if you look at this guy, you will notice that the NH is no longer complete here in case of the number of hydrogen atoms. So one hydrogen has been replaced. One hydrogen has been what? Replaced. So this is a secondary amine. This is a secondary amine. And you have the concept of N, you know, N alkyl. But the alkyls here, they are the same thing. Now this is what I'm going to do. We have N methyl amine. But why will I say methyl when it is the same group? Are you getting me right? That was that thing I was trying to tell you, that once, although I use alkyl, but if the groups are the same, you don't repeat it as, you know, alkyl. The proper thing to do here, I'm going to wipe, but let me write it. This thing you're seeing here is written as methylamine. But even so, because the groups are the same, we don't even need to put this N. If I just simply go and say, I just write dimethylamine, it covers. Dimethylamine, it covers. And that, of course, is what you're expected to do. So, having said this, I'm wiping this, and then since you have the same group, CH3 methyl, on this nitrogen guy, it's going to simply be dimethylamine. A chemistry student who meets this, someone who understands chemistry and IUPAC nomenclature, look at this and then know that, okay, I have the NH2, but that NH2, there are two alkyls, and the two alkyls are methyls, CH3. But now let me show you something. How would the person now know that the number of hydrogen is a 1 on nitrogen? This is because a nitrogen is surrounded by 3 bond lines, not 4 bond lines like you have in carbon. Okay, nitrogen is meant to be surrounded by 3 bond lines because it is trivalent. Nitrogen is trivalent. So, okay, if I have dimethyl, which is CH3 and CH3, automatically 2 hydrogens can no longer enter. It becomes only 1 hydrogen. All right, we are done with this. Dimethylamine, that's the name of the structure. This takes us to this next structure we have here. 5. The structure I have is C6H5, NH, and then CH3. Now, did you take note that the groups attached to the nitrogen are no longer the same? This is phenyl, and this is methyl. So here you apply your N-alkylamine, because the groups that you have there that are attached to that nitrogen, substituting for hydrogen, the groups are different. Are we together? So, having said this, you look at this is phenyl, this is methyl. Phenyl, the spelling starts with P. So, of course, you have to follow alphabetization to mention this. So, or to name this. Methyl comes before phenyl, M before P. So, this becomes N. You now have to indicate that on the nitrogen atom there is a substituent. One of the hydrogen has been replaced with something, either an alkyl or an aryl. Are you following right? So it becomes N-methyl phenylamine. N-methyl phenylamine. That takes us to number 6. I've got this one, CH3 and CH3. Now you notice something here. What did you notice? There is no hydrogen on the nitrogen anymore. All the hydrogens has been replaced. Need I forget this, please? Let me even tell you something. Remember, there was a time I made reference to ammonia, NH3. And you remember that to get a mean, what happens? An alkyl will come in or an aryl will come in, replacing 1 hydrogen in the ammonia. This is actually how amines are formed. They have a link to ammonia. Amine, ammonia, amine. I don't know if I'm communicating in any sense, right? I hope you're following this. So they have a link to this guy. In the case of amine, 1 hydrogen in ammonia is being replaced with either the alkyl group or, this guy could also be aryl, where you have your phenyl. So when more of the alkyl or aryl is now replacing the hydrogen, that is what gives you the class of this guy. So you want to just take note of this concept. No hydrogen on this nitrogen anymore. Then look at the substituent you have. All of them are the same. 3 of methyl. So there is nothing like NN in this case NN, methyl, methyl. You don't do that. Just simply go, since they are the same thing, you have your trimethyl. There are 3 methyl attachments. Trimethylamine. Trimethylamine. That's what you do. Remember, this is tertiary amine. Tertiary amine. Okay, this will take us to the last one, perhaps. Number 7, we've got this structure, C2H5 and C6H5, then CH3. Now look at this particular structure. Again, this is a tertiary amine. This is what? A tertiary amine. And what did you notice? The alkyl aryls, they are different. Like you have this alkyl, you have this alkyl, and then you have this aryl. One of these guys are taken to be what attaches to nitrogen to give you amine. For example, this ethyl to this nitrogen normally gives this RNH2, which is amine. Then these 2 guys replace hydrogen. Or you can say this nitrogen and this CH3 alkyl actually gives us our amine group. Then this and this replaces the 2 hydrogens that are follow come in that amine group. Or per se, you can say, okay, this phenyl is what came with this amine initially, that these 2 guys are hydrogen attached to nitrogen, so that this becomes an amine that has phenyl in it. Then the hydrogens here have been replaced by what? This alkyl and this alkyl. But naming all this, since this is tertiary, you are going to go as N, N, which shows that 2 groups, are you following right? Replaced nitrogen, replaced hydrogen rather, replaced 2 hydrogens that originally came with your primary amine. So NN, you cannot mention this, none of them is the same, right? These are 3 different groups. This is methyl, phenyl, ethyl. So it will go alphabetically: ethyl, methyl, then phenylamine. Phenylamine. That's how we gave the IUPAC nomenclature of this guy. NN, ethyl, methyl, phenylamine. This is cool. I hope you learned something wonderful from these structures, right? And the nomenclature that we have covered so far. And I'm very happy, you know why? Because with this, the GMAETS 41 has conquered all the IUPAC nomenclature for what I would call beginners. Beginners, yes, because we have other homologs which are no longer aliphatic. Like I said, for those in 200 level, there's one of the organic chemistry. I'll be taking them as well too. Hopefully tomorrow I'm going to introduce the IUPAC nomenclature. That is for bicyclo compounds. Bicyclo compounds. That's what these compounds are called. And of course, those compounds, they have what we call bridge head carbons. Bridge head carbons, you know. They are cycloalkanes. They are actually cycloalkanes. But you have maybe something like double cycloalkanes. Imagine I give you something of this kind. Something of this kind. You see? Maybe something of this kind. You know? This is not aromatic compounds. It's not. It's not aromatic compounds. And it could go in different ways. Could go in different ways. What if I draw something like this? What if I draw something like this? And then you have this. You're asked to give the name of this compound. We call them bicyclo compounds. But those ones are not meant for you friends in 100 levels, so it's not for you. I am done conquering all the 14 homologs you are meant to deal with in your Chem 102. The IUPAC nomenclature should no longer be your problems. Alkanes, alkene, alkyne, alkanols, alkanals. And I think alkanols per se, I have pre-recorded video lessons on them in this channel. Slide through to the GMAT 41's playlist, click on the playlist, search for Chem 102, and you would see, the video lessons covering these guys. Then, is it alkanone? And I don't know if I started from alkanone also, I've forgotten, but alkanoic acid, acid amide, acid chlorides. In the live section of this channel, you have a video lesson dedicated to that. And of course, today, we concluded, as you can see, with the nitriles, the acid anhydride, and of course, the amines. Share these video lessons to your friend and to your departmental WhatsApp group as well, to encourage your friends to subscribe to this channel. If you are yet to subscribe, please hit the subscription button, then turn on the notification bell so that anytime I have my classes, either live class or a pre-recorded video uploaded, you will be notified. Every day, something appears on this channel for someone to learn. So you want to always stay tuned because it might be something you need. But like I said, I've been able to work out a timetable and for how our online classes will be going, so you are aware and you would know that you are actually having a wonderful class on this channel. It will no longer be something open to chance. Any day I just come and host a class or whatever, or maybe when I am done with a particular class, I'll be telling you, okay, we might take this, we might take this, nothing like might again. We'll be sticking to that. So if you want to become a full member of this channel, yes, in order to gain full access to our classes, you just have to do something which is very simple. Like I said, GMAT 41 is an online school on its own. You see the way classes are being taken on this channel, full-blown lectures, right? So to become a channel member, hit the join tab on this channel, okay? And then, of course, once you click on the join tab, the GMAT 41's packages will appear. We have the gold level, the platinum level, the diamond level. Please, to be able to benefit fully from our classes, go for the platinum level and above. You can support GMAT 41 on the platinum level or diamond level. It's a monthly package. So every month you support the channel with that amount. I think 2,000 naira for the platinum level and 4,000 naira Nigerian currency for the diamond level. If you are not in Nigeria, let's assume you connect to our classes from any other country, can use the conversion index to know the equivalent so that you know what you are paying in your own currency. By this way, you will be supporting this platform, and of course, we'll be moving from height to height. And don't forget, always share the links to the GMAT 41's channel. I really appreciate that. If you have any question, remember, feel free to drop your questions, and of course, I'll respond to it. So, for those in 200 level, I'll be seeing you tonight, be taking you on Math 202. Yes, that's ordinary differential equation. Remember in our last class, we treated the concept of solutions to ODE. Today, we are still going to deal with that further. But don't forget, in our WhatsApp group for those in 200 level, or those offering ordinary differential equation, I am going to drop a video lesson to part 3 of Introduction to ODE. That part 3, it's for you to go and learn your standard integrals, integration. That is the third and last part of Introduction to ODE. If you've been able to cover part 1, part 2, that part 2 is what we are dealing with now, which has to do with, solutions to a differential equation. How would you know that this differential equation has this solution and what have you? So that is part 2 of the introduction. Part 3 is for you to know your standard integral. If I give you sine x and say you integrate it, what will you get? If I give you exponential 2x raised to the power 5, I say you integrate. How do you solve that? So you need to learn your standard integrals. And in our WhatsApp group for those in 200 level and other students, from anywhere offering ODE, I'll be dropping the link to that video. So you start working on it. In fact, within 30 minutes from now, I'll be dropping the link in the WhatsApp group of 200 level students. So you can start taking classes on standard integrals. 100 level students, you also need standard integrals because in your Math 102, you are studying integration fully as well. Do have a wonderful day left. See those of you that are going to connect to the live class later tonight. ODE, Ordinary Differential Equation, Math 202.